அந்த மாதிரி பண்ணிட்டு இருந்தாங்க. பட் இப்போ கொஞ்சம் அட்வான்ஸ் ஆயிடுச்சுன்னு தெரியுது.
ஓகே ஓகே. எங்க சார் இப்போ எங்க சென்னையில இருக்கீங்களா?
ஆமா சார், நான் இப்போ இப்போதைக்கு சென்னையில இருக்கேன். பட் என்னோட ஒர்க் லொகேஷன் வந்து டென்மார்க். ஆமா, நான் என்னோட பேஸ் ஆஃபீஸ் டென்மார்க்ல இருக்கு. இங்க இந்தியாவில் ஒரு பெங்களூர்ல ஒரு ஆஃபீஸ் இருக்கு. நான் இப்போ ஒர்க் ஃப்ரம் ஹோம்ன்றதுனால வீட்ல இருந்து ஒர்க் பண்ணிட்டு இருக்கேன்.
ஓகே ஓகே சார். 5 minutes சார் பசங்க வந்துட்டோம். 5 minutes சார்.
நோ ப்ராப்ளம் சார், நோ ப்ராப்ளம் சார், ஒன்றும் பிரச்சனை இல்லை. இது ஒன்றும் ஆக்சுவலி நான் வந்து I am planning to give it in 2 sessions. இன்னைக்கு வந்துட்டு I'm not going to go too much technically. ரொம்ப லேட் ஆயிடுச்சு. I have to consider the kids as well. So அதனால இப்போ இந்த செஷன் வந்து it's just going to be an introductory session மாதிரி. Next week if உங்களோட கரிக்குலம் பெர்மிட் பண்ணுச்சு அப்படின்னா then I will get into more technical details of all the FEA things, sir.
அடுத்த மண்டே ஆர் டியூஸ்டே பிளான் பண்ணிக்கலாம் சார்.
சார் மண்டே டியூஸ்டே I'll definitely talk to you and we'll have a proper timing on that, sir. அது மாதிரி பண்ணிக்கலாம். Today it's already 8. I don't want பசங்க எல்லாம் ரொம்ப டென்ஷன் ஆயிருவாங்க ரொம்ப இது பேசணும்னா. So ஒரு சின்ன இன்ட்ரோடக்ஷன் மாதிரி கொடுத்துட்டு then I'll just tell some interesting facts. என்ன நடக்குது இண்டஸ்ட்ரியில, என்ன நடந்துட்டு இருக்கு, டே டு டே லைஃப் எப்படி வந்து நம்ம FEA ஒரு கான்செப்ட் எப்படி போகுது அப்படின்றதையும் பேசிக்கலாம். அண்ட் சார் நான் அதுக்கு முன்னாடி ஜஸ்ட் டு நோ தி ஆடியன்ஸ், இப்போ வந்து ஜாயின் பண்ணிருக்கவங்க எல்லாருமே மெக்கானிக்கல் பசங்களா இல்ல?
மெக்கானிக்கல் only for mechanical students sir, almost.
ஓகே சார், அப்போ நான் வந்து தாராளமா சில விஷயங்கள் சில அப்ரிவேஷன்ஸ்லாம் சொல்லிக்கலாம். And sir, language barrier ne edha irukka? I can do it in English or in Tamil. Anything is fine with me. Okay.
Tamil or English, no problem sir.
English will be better sir, because ஒன்னு ரெண்டு பேருக்கு தமிழ் தெரியாம இருந்துச்சுனா அப்புறம் அது ஒரு பிரச்சனையா இருப்போது. Definitely. So it's 8. We'll wait for another minute sir, or we can join sir.
Can start sir, no problem. Vijayendran introduction மட்டும் கொடுத்துருங்க.
Okay. Welcome Gautam.
Thank you Vijay.
Yes, we on behalf of the management, principal, vice principal and the Department of Mechanical Engineering, I would like to welcome Mr. Gautam Rajasekharan for his guest lecture on the topic of finite element analysis and its application, its future scope and innovation. So a glimpse about his profile is he has vast experience in the field of FEA, where he has served for 2 years as a product support engineer in mining and the equipment industry, and he is having 9 years of experience in the FEA in wind domain, and he has worked with Vestas for 5.5 years and 3 years in Siemens Gamesa, and 9 months in Siemens Gamesa Denmark as a technical coordinator to Siemens Gamesa India, and 9 months in Denmark. He has worked there for 9 months, and currently he is working in the same firm, Siemens Gamesa Renewable Engineering Limited, as an associate manager since 2017 July. I would like to hand over the session to Mr. Gautam.
Thanks Vijaya for this. Just so you know, me and Vijayendran used to be classmates. And we used to attend FEA classes together. So it's just a lighter note. Now let me just get into the session. I don't know, am I audible first, and I'm also visually available for you guys? So okay, let me just share my screen. So like when I was asked by Vijayendran to give a session on this finite element analysis, everybody, or at least when I was doing my engineering, it was not a very happy subject to talk about. It's actually not preferred by a lot more people. Sorry? Hello?
Yeah, it's audible.
Yeah, okay. Why is that people are a bit scared of finite element analysis is because what is being taught, as rightly it should be, is the basics of FEA. In all the colleges, in all the curriculums, what they try to do is they try and teach you about the differential equations, the stiffness matrices, and your comparison of differential equations. There is a fun fact in this. We don't use any of these directly. You have softwares that will actually help you use all these things. What you're trying to learn in your curriculum from the Anna University or from any other institution for that matter is what happens in the background of these softwares. So what I can tell you is you can say 1 plus 1 and 2 in a calculator. You can always say 1 plus 1 is 2 in calculators. So you will know that yes, 1 plus 1 is 2. But then how did it do it in a calculator is what is being taught in school. So you cannot only go ahead with calculators, or you cannot only go ahead with schools. You need to have combinations of both. Now, for you to be a successful CAE engineer, let's not worry about FEA engineer, let's not worry about a design engineer or a CAD engineer. What you need is the basics correct. So if you can get the basics right, you can even do a PhD. What they would have done is like they would have I talked to n number of PhD holders all across the globe, and what I see is that they have a very strong basic. So that's what I am trying to instill in you, the urge to learn the basics right, and then go forward with whatever you want. The selection of stream can be possible only if you know the basics correct. So that is what I'm trying to insist. This is I've always been a fan of the basics, and that has helped me a lot, I could say. So let's, with that said, let me just give you a brief introduction of, for those who have joined after 8. I am Gautam. I've been working in FEA for about 11 years now. I've had opportunities to work in various softwares. I've had opportunities to work in various fields. I've been in heat transfer. I've also worked on your house ACs, how they try to take the heat away from the room. And I've also worked on the boilers where they have given the electricity to your house. So basically you can say that I've been your servant for quite some time. So and FEA is actually the core that is there in almost all the industries when it comes to product development and design validations. Now, when you say what FEA is at the core, what I mean to say is if you have a definitive design process in any of your small scale industry, or be it a large scale industry,
Gautam, mic open mic.
someone, I don't know.
Okay.
Okay. All right. Sorry. When you say, I don't know where I was lost, but anyways, I'll repeat the last sentence. When there is be it a small scale industry or a large scale industry, you need to have a validation. You are intending to do a chair which can hold, let's say, 200 kilos. How will you make sure that that chair will hold 200 kilos? Whatever chair you are sitting and looking at this computer right now, how will you know? How are you sure that it will withstand your weight? Of course, if you are weighing 200 kilos and less, then it will definitely withstand. But how is that you validate? You validate it by making a chair and keeping a 200 kilo weight on top of it. Now it is possible because it is a chair. It will cost you 500 rupees or maybe 1000 rupees. Now, can you do the same for a bike, or let alone a bike? Can you do the same for a car or an aeroplane or whatever? So you cannot physically create a test piece for every product that is produced in the world. So what do you do then? How do you advance the technology by reducing the turnaround time? There is something called a turnaround time in any product that you design or develop. A turnaround time means that when you start doing things in your chalkboard and when the product finally comes out. So let's say it takes 6 months for you to develop that. and try and produce it serial production. When I say serial production, you want to mass produce it. So that time taken for planning for the entire process is called a turnaround time. Now you cannot have a turnaround time for a bolt for like 10 months. You need to quickly produce bolts. So there are a lot of things that require optimization, and that's where FEA pitches in. Now, what is exactly FEA? So I hope you can see my slides too. See, like you can see that FEA is actually a mathematically representing a model using different stiffness equations. I don't know, sir, are the students permitted to allow or allowed to ask questions now, or can I ask them some questions? Actually, you are on mute, sir, but I don't know, many of them are not responding.
Yes, sir. You can ask, sir. No
yes. So how many of you have seen Matrix movie? You have seen the Matrix movie, right? Anybody from the students can answer? Okay. Anyways, I think everybody is muted, so so it is Matrix is actually a representation of math or FEA. If you read the book, you will understand. So matrix is actually a representation of FEA, or mathematically representing an object by using electrical signals. That is matrix. So you can actually represent anything by using FEA. Like what I have given you is just a pictorial representation of how a shell element will be represented using a stiffness matrix. So the basic, there's only one formula in FEA. There is no other formulas in FEA. That is the one good thing about it. F is equal to KU. Forces equal to stiffness into your displacement. That's all. So every formula that you read in your SOM, in your KOM will come inside this formula. So it's very easy if you understand it right. If not, then it will always be an issue. I'll give you something. I know it is not that good to tell this. When I was doing or studying my FEA, I actually failed in this subject. I had to challenge this and clear it from Anna University. I was like that. But the concept of what was taught, I had understood, and that actually helped me in cracking the interviews in all the major companies. So it's not about what you are reading in the book. You find it difficult, you cannot just sir, they are having the stiffness derivations and all in their lessons, right now. Yes, the chapter they are having stiffness derivations. Those stiffness derivations are basics. You need to know them just enough to get a pass mark. But once you understand the concepts, you can apply these stiffness equations anywhere. You can actually get a result much quicker than your normal hand calculations. So that is why FEA is like the king of all validations right now. Right now you have almost XYZ, 90%, 95% of their companies use FEA as a tool to validate their designs. You have 1,000 design engineers, you'll have 2 FEA engineers. But those 2 FEA engineers are the ones who are running the show in a company. So you cannot release a product unless there is an FEA engineer coming and saying, hey, this product is fine, you can release it. So that is the importance of FEA in today's industrial life. So when I'll tell you some interesting facts, FEA was actually developed by a Russian called Boris Galarkin. He actually, what he did was, he took a problem, he took a bridge actually, he tried to assign some functions to this bridge by mathematically building some points. That is what you call a mesh. So he tried doing it by hand. He only did 2 functions. So he got a result. Let's say function A gave a result, function B gave a result. So he compared these 2 functions. No matter what your problem is, when you assign some values to it, you will know what is the depth of your problem. So that is what is the basis of FE. So let's assume that you have a bridge, you put a 50 kilo person, you put a 100 kilo person. How much did the bridge deform? Now, based on comparing this, finitely comparing this, you can arrive on to any solutions. That is the basic of FE. I can elaborate this, but I don't want to go in depth. I'll just this is the introduction. No, not many would be knowing this. Russian Boris Galarkin, but he is the father of FEA. So, and there's one more thing. FEM is not FEA. Finite element method is not finite element analysis. There is a difference. Finite element method is a mathematical concept. When I say mathematical concept, finite element method is actually as simple as a Fourier transform. Fourier transform is a mathematical concept. Finite element method is also a mathematical concept. So you cannot, sometimes, they generally say FEM and FEA are equal. No, it is not so. When someone says that, please correct them. FEA is applying FEM and analyzing something. So it is an extended use of some product, some design, and also a mathematical representation of a model. So that is FEM. Now, how do you do it? You have a lot of in-house softwares. You have Ansys, Abacus, Simulink, Altair, whatnot. I'll tell you an interesting fact. Boeing, Rolls-Royce, Pratt and Whitney, Lockheed Martin, they don't use any of these softwares. They have their own in-house softwares, meaning they do not use Ansys or they do not use Simulink or SolidWorks. They have developed their own FEA softwares in their company, and they are using those softwares to analyze their products. Now, this will ensure them complete secrecy. That's why Boeing and Rolls-Royce. Rolls-Royce is the biggest. I know Rolls-Royce, everybody knows about car, but Rolls-Royce is the biggest industrial aviation engine manufacturer. So followed by GE, followed by Boeing, followed by Airbus. In fact, Boeing and Airbus, they buy their engines from Rolls-Royce. So these guys, they are pioneers in FEA. In fact, one of the primitive users. How many of you know a flight called Spitfire? This is actually a Spitfire is a British flight used in World War II for bombing. It's a fighter pilot. It's a fighter plane. Sorry, those Spitfires were one of the initial aircrafts to use FEA in their manufacturing, and they didn't have computers to do it. They did it by hand calculations. They used FEA to simplify a problem, and then they started doing it. So now it has come to a stage where you have 99.9% of your products that you use day to day, be it your cell phone, be it anything you want, be it the same laptop that you're using, it uses FEA not only to validate it structurally, but also to validate it. Even you have chips that can give you the heat dissipations of something. So whatever you use, you have wherever there is a manufacturing, there will be an FEA now. So it has come to a stage. So it has come to a stage that even dams, our Indian government has recommended FEA purposes to simulate the hydrostatic pressure created by the water stagnant on dams, and they are doing strain problems on FEA to find the weak spots in the dams. So it has gone to a level where we are relying an entire city's future on FEA. So it has come to a level, there it is. Now, why fiddle with this? Simple reason, money. Why do you want to have FEA in your thing? Is because you want to have a quick turnaround time first, and you want to rely on things. You can buy a car. Let's say you buy your latest car, whatever Seltos maybe. You go and crash it at, let's say, 60 kilometers or 70 kilometers. How will you be sure that the rating that is given by the car is safe? Now you need to validate those. Now you want to test it. You want to put your life against it? No. What you need to do, you need to simulate the similar situations and reduce your turnaround time. Give a product which is cheaper and at better quality. That's why you need them. I'll tell you an interesting fact. The FEA usage in mechanical industries was not promoted by any of the mechanical industries. It was actually promoted by an insurance company called Lloyd. So this Lloyd is an insurance company from UK, which wanted to verify before giving insurance money or insurance cover to the shipbuilding industry. So when a shipbuilding industry started producing things, they want all the owners who purchased the ships, they wanted to insure their ships. Now, Lloyd was ready to do that when there was no FEA. What they did is it would just create some tests that itself would cost them a lot of money, and then they will give assurance that okay, you can take an insurance sum of this much for this particular ship. Later, when the ship started to fail, Lloyd ended up losing a lot of money. So they wanted to devise a plan where you can validate your product by a mathematical or a paper-wise representation, which is reliable. That is why FEA was introduced into the manufacturing industry. So you should give a credit to all the commerce students in Lloyd who were wanting to use this mechanical tool to get the process of manufacturing speeding up. So this is something that was really interesting to me. So I thought I'll just share it. Again, coming down to uses of FEA, you have n number of uses. I'll just try and list what all is there. You have the automobile, which you use it for your crash test. You do one crash test physically. That is what is done by your ARAI. That gives you the NCPPA. These are the bodies that does if Ford is releasing a car, if Kia is releasing a car, if Hyundai is releasing a car, they'll take the car and they'll go crash it at 60 kilometers per hour. That's right. In India, it is on the crash test limit is only at 60 kilometers per hour. So if you are going at 80 and you crash the car and you die, it is not the company's or India's the government responsibility. So how this crash is done? First, what they do is they create the crash, they simulate the crash on software, that is your FEA software, and then they have, let's say, a result which says that this will deform X millimeter. Now the test when they are doing should also deform only that much millimeters. Let's say the crash you have in your FEA is deforming, say 100 millimeters, it is deforming. The bonnet is deforming by 100 millimeters. The test also should deform only by 100 millimeters. If these two match only, they will certify you. Meaning you need to keep your calculations ready to get certified for any product. So that is where your in automobile it is used. In aerospace, there's an interesting fact. For cars, this factor of safety that we use is somewhere around 3 to 5. That is the factor of safety we use. For aeroplanes, the factor of safety we use is somewhere around 12 to 15. So meaning, if you're designing your aeroplane for one people, you need to make sure that it should be at least 15 times safe. That's when you will be allowed to produce it or manufacture it properly. This is a general figure. It depends on components to components. I'm putting a disclaimer right there. But generally, they say that you need to have something safer 15 times. Meaning, you can die of a heart attack in a plane, but you will not die of a crash. That's how they are trying to take it forward. So you have n number of applications. In cinema, FEA is used. I don't know if you know this movie Interstellar, where you have a giant black hole called Gargantua. This Gargantua is actually a proper representation of mathematical theoretical physics. There is a physicist called Kip Thorne. You can Google him up. Christopher Nolan and Kip Thorne are buddies, and they when Nolan went to Thorne for this, he had devised a mathematical equation which was simulated using FEA, and what you see as a galaxy is actual FEA simulation. So this was a shocker to everybody in the FEA world, because nobody anticipated that this will. In fact, they have even filed a paper on this. The movie has actually filed a paper on this, so you can Google it out. If for those who are a bit movie fanatic, you can Google this out. So yeah, that's something that is was I thought it should be interesting for people to see. Now coming to one of the particular uses, what I am working in, I'm working in wind industry. I design and validate wind turbines. So how, like, just to give you a small introduction about it. So what happens in a wind turbine is that you take the potential energy of the wind, potential and the kinematic energy, of course, and you try and convert it into a mechanical energy, which will in turn rotate a generator, and it will produce power, basic stuff. Okay. So the thing is, this looks simple. This really looks simple, but it is not so. For example, we are looking at 3 to 4 megawatts of electricity that is produced in India. In India, you don't have that much winds. When the wind energy itself, when you are at the near the poles, you have, when I'm saying pole, North Pole and South Pole will have more wind. When you come closer to the equator, the winds will reduce. So when you are coming closer to the equator, what happens is that when your wind is reduced, but your solar power is increasing. So renewable energy is always a factor, but it is much more greater when you are at the poles. But near the poles, there is always this problem. You will have extreme weather. You'll have minus temperatures. You'll have typhoons. You'll have like you can see Arctic Circle and Antarctic Circle. They are always in minus. So how do you put a turbine, or how do you place turbines if you want to take more power in an extreme weather environment? So you need to design it in such a way that it is impeccably strong. You need to make sure that your quality of design is very accurate. You need to validate, you need to foresee so many scenarios. What if there is a typhoon? You are in the middle of an ocean. You have installed a wind turbine in the middle of an ocean. The wind turbine will somewhere weigh around 650 tons. That 650 tons is floating in water by using one of these floats. So it's actually floating in water. Now, what if there is a typhoon? What if this one falls? One wind turbine will easily cost about 24 to 30 million euros. Now, that 30 million euros, you will just drop it in sea. You won't get an Oscar for Titanic like this. So you need to be really, really precise in your calculations, precise in your applications of FEA, wherein if I'm going to put this here, definitely it should not fail. So that is why you need FEA in not only here, any industry which has its product above €1 million. Let's say you want to buy a plane. You wouldn't buy a plane if it is not certified, and you need FEA to certify it. Correct? Now let's say you buy a car. You are going and checking what is the safety rating. So somewhere you are like asking for a certificate, which means that you need to validate your component. Now that component validation is only FEA is able to do that so far successfully. Now there's an interesting fact. Right now I'm working on a turbine which is 8 megawatt, which means it can produce power that can give you 8 megawatt of power for 1 hour of rotation. So when it rotates once, it can power your house for 1 year free. So right now it is an offshore turbine. It is going to be in Denmark because we don't have that much forceful winds here. Even if you put this turbine, it will not rotate because you need that much strong winds. Only in Arctics you get this. So they have found it cheaper to put it in one remote location of a sea and take the wire from there and power the land with it. And they are putting about 8 to 12 gigawatts of power. 8 to 12 gigawatts is enough to power a small country for a year. So they are doing that. Now just these are all pictures that I've taken from the internet. For NDA reasons, I cannot show you any of my current designs. I am forbidden by the company to do that because I work in an R&D facility. But what I'm showing you is all these are actually factors where FEA plays a role. When I'm saying, see, these are very expensive machines. Trust me, when you come and stand next to this, you know how much you will be. You will not even come to the first part of this. This is so big. This is about 12 meters in diameter, and you're just 1.2 meters tall. So when I'm saying 12 meters in diameter, the weight of it alone is 450 tons. So just the outside of it is alone 450 tons. So when you are having a 450 tons, the self weight alone is enough to crush it. Now, when you are having a self weight and you have such a big component or such a big diameter, what you will do is you will do a buckling analysis. A buckling analysis is that it should not, whenever you're putting a tower, it should not collapse on itself. So there is a lot of analysis that you can do. If you're building a building, if you're building a bridge, what you do is a response analysis or a seismic analysis. What if there is an earthquake?
Now, how do you simulate that situation? So you know the forces and moments that's gonna come. That's when your EMEC, sir, they are having EMEC, right, sir? Engineering mechanics, they are still having it, right, sir? So that's when your EMEC will come into picture.
Yes.
Okay,
We have
so you know the dimensions of bridge. Let's say the bridge is 300 meters long. You have points at these levels. Now you know if there is going to be a 5.5 Richter earthquake. So what will be the force that will be coming onto the bridge on the foundation? So you will know the forces. All these have calculations. So these calculations will be fed into the uh, what do you call as FEA software, and they'll do a seismic analysis and they'll give you a response. Meaning, if there is a 5.5 earthquake, this bridge will sustain. If there is a 6 earthquake, this will not sustain. If there is a 7, then you need to make sure that. So based on the level of this thing, based on the level, you are giving them a lot of options to prepare yourself for a disaster. So all that is also coming into picture. The same, likewise, all the towers are also having this thing. I'll give you a tips whenever you are having a wind turbine, whenever you see a wind turbine, let's say you go towards Tirunelveli or towards north of India, or you will see wind turbines. When you're seeing the wind turbines, it looks that it looks like it will rotate slowly. Let's say about 10 or 12 RPM is the speed of it. But if you are somehow, if I tie you to the tip of that blade, you will be moving at 208 kilometers per hour. 60 meters per second when you compute it, it is pi r. So you will be moving at 200 kilometers per hour. Now you imagine if you are moving at 200 kilometers per hour and you apply the brakes suddenly, there is something called mass moment of inertia. It is easier to stop a car which is moving at 60 kilometer speed than it is to stop a train which is moving at the same 60 kilometer speed. Why? The reason is mass moment of inertia. It's simple. Train has a much more higher mass moment of inertia, and then the car than the car. Car's mass is what? Say about 1,000 kilos or maybe 2,000 kilos. Trains, you can say it is easily 1 lakh ton or something like that. So stopping a 1 lakh ton vehicle, you imagine what is the brake that is needed. Now I'm talking about trains. Now when I'm talking, the moment will be in e to the power 7 or e to the power 8. When I'm saying e to the power 8, let's assume it's 2 into e to the power 8 Newton meter, or Newton meter is the unit of moment. So that moment is if let's assume that you are supposed to hold that moment, you will be disintegrated. If you can concentrate that moment on your body, it will disintegrate you into atoms. That much force is there. So how do you do it? You use brakes at multiple levels, right? Now the same way, this wind turbines also uses brakes at multiple levels. Now you can see in any, if you apply a load on say 10 to 12 kilonewton, that is a very huge load. 10 to 12 kilonewton is a huge load. When you apply that onto a 1x1 bar, you will find a deformation of, say, the deformations will always be in microns, maybe 2 or 3 centimeters or 2 or 3 millimeters. But in these big machines, you will find the deformations in let's say meters. When I'm saying meters, it's when you have a deformation in meter, it means that you have designed it to be 60 mm. It will be 60 meters. It will become 61 meters. So you imagine the kind of stress. For you to stress any object, if you elongate it by 1 mm, it will be in very high stress. Okay, so you can always pull your finger by 5 mm. But if you want to pull your finger by 10 mm, then your finger will come out of your body. So everything is deformations. When you are so if you are having deformations in meter, it will always stress you. It will when you design an object, the object should be designed in such a way that it should not cross its strain limit, which is your plastic strain. I hope you guys know what is strain, plastic strain, elastic strain, and ultimate strain. So for you to not cross plastic strain, it should have 0.01% of deformation only. So if you are creating an object, let's say 100 mm, you can actually allow it to deform only 1 mm. then only it's a rough thumb rule. It depends on the material properties again, but it's a rough thumb rule that you can only allow it to deform 1 mm. Now I'm showing you a deformation which is 15 mm. So it's 15 times more stressed. This object is 15 times more stressed. That's what you're seeing from the FEA. So this will give the designer a clear idea where he should strengthen his structure. I hope you're all able to see my screen. So this is how FEA is helping the engineers to give a design which will not fail in the field. This is life or death situation. If a wind turbine which is installed in land fails, the blade will be thrown out to 6 to 8 kilometers. It will be thrown out when it is rotating, and somehow the blade mounting fails. You imagine if it is 6 to 7 kilometers away from the city, it will go and fall on the city, and that blade is about 108 meters. What you run is 100 meters track you are running, right? It is 108 meters. Now imagine 108 meters, you can have 8 to 10 houses just taken away. The weight of the blade is so large. So you need to be very precise in your calculations, and that's where FEA comes in. So moving on to the now see, so far what they are doing is they are mathematically representing something. They are designing first. They will design engineer, a CAD design engineer will give you a design. He will try and the FEA engineer will try and mathematically build that model design using FEA methods. Now there is a new concept which is coming into action, or which is more and more implemented very fastly, is the digital twinning option. Now what is this digital twinning? See, this is actually a Rolls-Royce engine, what I'm showing you. This is your Boeing 747 engine, which is collaborated with Rolls-Royce. Now what is happening is, when you try and design this engine, what they'll do is they'll first model it in Pro-E or CAD or whatever software you're using, let's say Autodesk also. They'll give you the model in step or parasolid file. You take it into your FEA. You may analyze it by meshing it and then applying the boundary conditions in all loads. You will apply it, and then you will come up with a result. Based on that result, people develop a prototype. When they are doing a prototype, then they will test. They will put it in a chamber and then they will test all those things. But now the companies, to earn more profit and also eliminate a lot of uncertain process, what they are trying to do is to acquire this digital twinning method, meaning they will use a FEA software to create a prototype once. Once the prototype and FEA results are matching very accurately, from the next iteration onwards, they won't build a prototype. They will only go with FEA. So what is saved there? Prototype costing is completely saved. All right. So meaning you can have quick turnaround times. For you to machine a product, it takes say 8 hours or 10 hours or something. Or for you to manufacture a product, for you to model a product, it will not take 8 hours. It will probably take 1 hour. You get my point? So that is the reason why you are why they are going into the next level of FEA. So it is the right time for you guys to seriously use this as an option for your career. And then see, the best part of digital twinning is you get to be Iron Man. You can actually have voice command operated virtual interface digital twinning, meaning what Jarvis is doing is like that's a little bit cinematic, but you can come very close to it. We are actually exploring this digital twinning option where we can actually reduce a lot of in-person or disaster management techniques. If there is a disaster, what will fall first? How can you build a tunnel if a underground tunnel collapses? How can you put a vent? So all that is actually being taken care of by that digital twinning. So summing up, FEA is fun, really a very good topic, but only if you know your basics right, period. You need to concentrate on your basics. In fact, I cannot turn this camera around. I still have all my books. I refer them if I am getting in trouble. All the basic formulas, I still refer them. I still try and implement whatever I've learned in my engineering in my work. It is not easy, definitely. It gives me a lot of sleepless nights, but it's worth it. So what you need to do is, if you can see my screen, I don't know if you are still having these, sir. Please confirm me if they are still having these topics. So when you are, this is a normal layout of what happens in an industry. So you have a concept stage. Someone will come and tell you an idea that we need to develop something. Then there will be an initial design. When you're having initial design, you'll have strength of materials coming in, kinematics of machines coming in, design of machine elements coming in, and manufacturing of machines. That is manufacturing process. So all these things, the basics are actually here. So if you know these, yes, of course, you will get trained in the job, but you're learning them. This is a very good opportunity for you to grasp as much as possible. And then, when you come out, you can always answer a question. Hey, this will be stressed, because I know stress by deformation is what? Stress by strain. So I know this will be stressed. I'm seeing this was deformation. So you need to design this better. So you will be in a better position to answer the questions. When it comes to design validation, of course, once your initial design is confirmed, it will go back to design validation. If it is not, then it will go back to the concept stage, of course. Then when it comes to design validation, that's where your FEA comes in. And of course, your manufacturing process also will come in, because you need to build a prototype, correct? So that is also coming in. And then when it comes to prototype testing, you will be putting in a lot of sensors, a lot of accelerometers, a lot of other things. That's where your mechatronic comes in. So when I'm seeing all these patterns, I see that, okay, someone in university had some brains to give us what we need when you go into an industry. So, and then you have production, of course, you have the operation research process coming in and all. So all these things are taught to me when I was about 10 or 11 years younger, when I was in my engineering. And now you guys are there. I want you to take in as much as possible. And then when you're coming out, you can be better engineers. Right now there is a slump, but we can always improve ourselves if we know the basics right. So that's my summing up. In case if you have any questions, please reach out, or you can ask them now if we have the time. And yeah, if there is a project query, please do reach out. I think I can ping you my number. I can help you out if it's off hours. I cannot help you during my office hours, but if there's any questions that you guys have, you can please approach me. No problem. I'm handing this back to sir and Vijaya.
Yes, sir.
Please
The students has any queries regarding FEA?
Anybody have doubt, you please feel free to ask him.
In any language, தமிழ்ல கூட கேட்கலாம். In any language, தமிழ்ல கூட தாராளமா கேட்கலாம். ஒரு பிரச்சனையும் இல்ல.
Anybody?
கௌதம், நீங்க வேற ஏதாவது சாஃப்ட்வேர் படிச்சிருக்கீங்களா? விண்ட் தனியா சாஃப்ட்வேர் இருக்கு ஏதாவது?
இல்லைங்க, அந்த மாதிரி எதுவும் கிடையாதுங்க. FEA நான் விண்ட்ல இதுக்கு முன்னாடி வந்து நான்
விண்ட் டர்பைன் ஏதாவது தனி சாஃப்ட்வேர் விண்ட் டர்பைன் அந்த ரெலவெண்டா ஒரு ஜாப் ஆப்பர்ச்சுனிட்டிஸ் தேடும்போது ஏதாவது அடிஷனல் கோர்சஸ் ஏதாவது இருக்குங்களா?
இல்லைங்க, அப்படின்னு எதுவும் கிடையாது. விண்ட் எனர்ஜின்றது வந்து பேசிக்கா உங்களோட ஒரு ஆல்டர்னேட்டர் ஒரு கவர்னர் தான். அந்த கவர்னரை வந்து ஸ்ட்ரக்சரல் இன்ஜினியரிங் பேஸ் பண்ணி தான் வந்து நீங்க எடுத்து மேல வைக்கிறீங்க. இன்ஃபேக்ட் நீங்க இந்த இது பாத்தீங்க அப்படின்னா விண்டோட மொத்த ஸ்ட்ரக்சருமே இவ்வளவுதான். ஆனா இதுல இருக்கிற கால்குலேஷன்ஸ்ன்னு பாத்தீங்கன்னா வந்து எல்லாமே பேசிக்ஸ் ஆஃப் SOM or MOM. இது விண்டுன்னு மட்டும் இல்லை சார், எனி சாஃப்ட்வேர் ஃபார் தட், எனி industry for that matter, when you break it down, it will be basics. மெக்கானிக்கலை பொறுத்த வரைக்கும், நான் மெக்கானிக்கல் பொறுத்த வரைக்கும் சொல்றேன், விண்டுக்குன்னு தனியா கோர்ஸ் இப்போதைக்கு கிடையாது. சில யூனிவர்சிட்டிஸ் இன் டென்மார்க் ஆக்சுவலி இருக்கு. நாங்க இட் இஸ் ஆக்சுவலி தேர் இன் டென்மார்க், அண்ட் ஐ ஹவ் ஆல்சோ பீன் தேர். அந்த இடத்துல வந்து it will be a specialization, as in it will not even be a course. இந்த ஒரு ப்ராப்ளம்னு வருதுன்னா அந்த ப்ராப்ளமை சால்வ் பண்றதுக்கான ஒரு இடமா மாதிரி அந்த இடம் இருக்கு. ஸோ there is no direct courses as such.
Right now, Anna University, there is no separate subject for design of wind power windmills.
Correct, sir.
In Anna University, is not there actually.
இல்ல இப்போ இல்ல, முன்னாடில இருந்தே கிடையாது. What we are dealing with is basic design of machine elements.
Yes, sir.
So we are trying to our in fact I still use the data book sometimes. We are trying to get the we have our own standards, Euro standards and mari standards irukku. We are trying to get those things implemented in our basic designs. It's a very simple design. Aero mari இதுக்கு கோர்ஸ் இருக்கான்னு கேட்டா பிளேடுக்கு மென்னா இருக்கு. பிளேட்ஸுக்கு காம்போசிட் இன்ஜினியரிங்னு சொல்லிட்டு அந்த கோர்ஸ் இருக்கு. பட் தட் இஸ் ஆல்சோ காம்போசிட் கோர்ஸ் தான். மெக்கானிக்கல் இன்ஜினியரிங் மாதிரி அதுவும் ஒரு இன்ஜினியரிங் தான். ஸோ விண்டுக்குன்னு தனியா எதுவும் கிடையாது சார், எனக்கு தெரிஞ்ச வரைக்கும் இல்லை சார். உங்களுக்கு ஏதாவது தெரிஞ்சதுன்னா சொல்லுங்க சார், நானும் படிக்கிறேன்.
So what about the job opportunities in this line, in this field?
சார் in this field இல்ல, any renewable field சார். இப்போ கிளைமேட்டிக் சேஞ்ச்ல நம்ம வந்து பயனியர். நம்ம வந்து we are leading a belt where நம்ம ஆப்கானிஸ்தான், பாகிஸ்தான், நேபாள், பூட்டான் and on the side Kyrgyzstan கொஞ்சம் side. So we are going to supply solar panels to all these countries at a very subsidized price. இது வந்து இந்த பாரிஸ் அக்கார்ட் இருந்ததுல சார், கிளைமேட்டிக் சேஞ்ச் பாரிஸ் அக்கார்ட், இந்தியன் கவர்மெண்ட் எடுத்துக்கிட்ட இனிஷியேட்டிவ்ஸ். எப்படி இனிஷியேட்டிவ்ஸ் வரும் அப்படின்னா, ரெனியூபிள் எனர்ஜி இஸ் கோயிங் டு பி தி ஃபியூச்சர். இனிஷியேட்டிவ் எப்படி எடுத்திருக்கு இந்தியன் கவர்மெண்டோட ஸ்டாண்ட்ஸ் என்ன அப்படின்னா, நான் என்னோட எமிஷனை குறைச்சிக்கிறேன், அடுத்தவங்களோட எமிஷனை குறைக்கிறதுக்கு ஹெல்ப் பண்றேன் அண்ட் டெக்னாலஜிக்கல் சப்போர்ட்டும் கொடுப்பேன். அதுதான் வந்து நம்மளோட கையொப்பமிட்ட ஒரு இது என்னன்னா இதுதான். ஸோ இந்த இதுல வந்து ஜாப் ஆப்பர்ச்சுனிட்டிஸ் ஆர் ஆக்சுவலி ஹை. நவ் renewable energy is being given a lot of boost. Nobody wants to get into oil and natural gas. Everybody wants to make a renewable energy because the climatic change accord by government's push we are doing it. So இது இந்தியால இவ்ளோ இருக்கு அப்படின்னா நீங்க மத்த நாடுகள்ல யோசிச்சுக்கோங்க. இன்ஃபேக்ட் இந்தியால வந்து we are only using 20% of renewable energy in day to day life. Denmark, UK லாம் they are aiming for 80% renewable energy. எலக்ட்ரிக் கார்ஸ் என்னைக்கு நம்ம மார்க்கெட்ல வர ஆரம்பிக்குதோ அன்னில இருந்து ரெனியூவல் எனர்ஜியோட மவுத் எப்பயுமே அதிகமாயிரும் சார். when you use locomotives for electrical purpose then you need to make the source available for it. அதனால definitely there will be in not only mechanical industry opportunities. நீங்க இண்டிவிஜுவலாவே a lot of my friends or individually இங்க என்னோட வேலை பார்த்தவங்க வேலையை விட்டுட்டு they started manufacturing electric renewable panels and they are leading a very good business. So there is opportunities, sir.
Thank you, sir. Thank you.
No problem, sir.
Okay, Gautam, thank you for your wonderful lecture.
Wonderful lecture la adu illapa pasangala, if there is any questions
you are coming over here.
sorry பசங்களுக்கும் நான் சாரி சொல்லணும். நான் ஒரு இதுல ஒரு எமர்ஜென்சி ஃபெயிலியர் ஒன்று நடந்துருச்சு, அதனால அங்க ஆக்சுவலி டே லாங் மீட்டிங் அது நான் மாட்டிக்கிட்டேன். அதனாலதான் 6 to 7 இருந்துச்சுன்னு நினைக்கிறேன். 2 hour தள்ளி போட வேண்டியதா போயிருச்சு. ஐ எம் ரியலி சாரி ஃபார் ரூயினிங் யுவர் ஈவினிங். If there is anything, I don't know how to. I think the DMs have been deactivated. So என்னோட நம்பர் I can give you the number to Vijayendran. Vijayendran has my number. If you guys need any help in your projects, if you are looking FEA as your career options and you need to have some talk, you're always welcome. Please give me a call. I'll try and guide you with whatever experience I have. எனக்கு எல்லாம் தெரியும்னு சொல்ல, I can still guide you.
Yeah. Okay, sir. Okay. Thank you, sir. Thank you very much for your nice presentation, sir.
Thank you, sir.
Sharing your industry experience to our students.
Sure, sir.
We need one more meeting, sir. Next.
Yes, sir.
Most probably
That will be a little bit technical.
Yes, sir. No problem, sir.
இப்போ நான் வந்து டெக்னிக்கலி எதுவுமே உள்ள போகல. ஜஸ்ட் கிவிங் யூ an overall picture. FEA-ல டெக்னிக்கலா எப்படி செய்யலாம் அந்த சென்ஸ் சாஃப்ட் டூல் வைஸ் ஐ ஒன்ட் கவர். நீங்க டூல்ன்றது வந்து கார் மாதிரி சார். FEA-ன்றது கார் டிரைவிங் தெரியற மாதிரி. உங்களுக்கு டிரைவில் தெரிஞ்சதுன்னா எந்த டூல் வேணாலும் நீங்க ஓட்டிக்கலாம். ஸோ எந்த டூல் வேணாலும் நீங்க யூஸ் பண்ணிக்கலாம். ஸோ அதனால நான் ஐ ட்ரை அண்ட் கிவ் யூ சம் மோர் பேசிக்ஸ் ஆன் ஹவு டு கால்குலேட். மேபி நாட் கொஞ்சம் கேப் விட்டு கூட நான் செய்றேன். இஃப் எனி இன்ட்ரெஸ்டட் ஸ்டூடெண்ட்ஸ் தே வாண்ட் டு ஹேவ் எனி பர்టిక్యులர் டாபிக், அதுவும் ஐ அம் ஓபன் ஃபார் எக்ஸ்பிளைனிங்.
Okay, sir.
Okay, sir.
Sir, how to validate, sir?
Bye.
Sorry?
Sir, how to validate? Because it's an approximate method. Hello?
Hello?
Yes,
சொல்லுங்க.
Sir, கேக்குதா சார்?
கேக்குதுங்க சார், சொல்லுங்க.
சார் இப்போ வந்து நம்ம FEA-ல ஒரு ஆன்சர்ஸ்க்கு வந்து ஒரு சிம்பிளிஃபை ஒரு யூரியல் பாயிண்ட் லோட் வந்து நம்ம சால்வ் பண்றோம் அப்படின்னா அனாலிசிஸ்ல நம்ம ரிசல்ட் வரும். ஆனா அதே இதை நம்ம வந்து வெயிட்டட் ரெசிடியூ மெத்தட்லயோ இல்ல ரேலரிட்ஸ்லயோ நமக்கு வந்து அந்த ஆன்சர் கொண்டு வரும். ஒய் அதாவது டிஃப்ளெக்ஷன் வந்து y ஈக்குவல் டு WLQ/48EA அப்படின்னு நம்ம வேலிடேட் பண்ணிடலாம். ரெண்டுமே சேமா இருக்கிற மாதிரி. அதுக்கு வந்து ஒரு கிராஷ் அனாலிசிஸ் நடக்குது. ஸோ ஒரு கிராஷ் அனாலிசிஸ்ல இது அந்த பேனட்டோ மற்றதோ டிஃபார்ம் ஆகுது நம்ம கண்டுபிடிக்கும் த்ரூ FEA அனாலிசிஸ். அதை எப்படி பண்றது?
ஓகே, நீங்க வந்து இப்போ ஹேண்ட் கால்குலேஷனும் FEA-வும் வேலிடேஷன் பண்ணிட்டு இருக்கீங்க. ரெய்லரிட்ஜ் மெத்தட்ன்றது ஒரு இப்போ ஒரு மேட்ரிக்ஸ் இருக்குல்லங்க, அந்த மேட்ரிக்ஸை சால்வ் பண்ற மெக்கானிசம் தான் ரெய்லரிட்ஜ் மெத்தட். அதுலயே இன்னொரு மெத்தடும் இருக்கு, நியூட்டன் ராப்சன்ஸ் இருக்கு. அதாவது நீங்க இப்போ நான் இன்னும் சிம்பிள் டேர்ம்ல சொல்லணும்னா, ஒரு ப்ராப்ளம் இருக்கு. அந்த ப்ராப்ளமை நீங்க கேசியோ கால்குலேட்டர்ல கால்குலேட் பண்ணலாமா இல்ல வேற ஏதாவது ஒரு கால்குலேட்டர்ல கால்குலேட் பண்ணலாமான்ற மாதிரி, அது ரெண்டுமே ஒரே ஆன்சர் தான் கொடுக்கும். 1+1 2ன்றத வந்து நீங்க 2+3 is 5ன்றது 3+2 5 தான். ஸோ ரெய்லரிட்ஜ் மெத்தடுக்கும் நியூட்டன் ராப்சன்ஸ் மெத்தடுக்கும் இவ்வளவுதான் வித்தியாசமே தவிர, அது யூஸ் பண்ற மெத்தடாலஜி அந்த இப்போ இந்த FEA சாஃப்ட்வேர்ல எனக்கு 2 ஆப்ஷனும் கொடுத்துருப்பாங்க. ரெய்லரிட்ஜ் மெத்தடும் கொடுத்துருப்பாங்க, இந்த மெத்தடும் கொடுத்துருப்பாங்க. நான் அது என்னோட யூசேஜுக்கு ஏற்ற மாதிரி நான் மாத்திக்கிடுவேன். அது எப்படி சொல்றது அப்படின்னா, இப்போ திடீர்னு வந்து எனக்கு இது ஃப்ராக்சர் ஆக போகுது, கிராக் ஆயிடுச்சு அப்படின்னு சொல்லிட்டு சில ப்ராப்ளம்ஸ் வரும். கிராக் ஆயிடுச்சுன்னு இந்த ப்ராப்ளம்ஸ் வரும்போது ரெய்லரிட்ஜ் மெத்தட் யூஸ் பண்ணனா என்னோட ரெசிடுவல் ஃபங்க்ஷன் ரொம்ப பெருசா போயிடும். அது கிராஷ் ஆயிடும், சிஸ்டமே கிராஷ் ஆயிடும். ஸோ அப்போ நான் நியூட்டன் ராப்சன்ஸ் மாத்திக்கலாம். நீங்க இப்போ உங்களோட கொஸ்டின் வந்து ரெய்லரிட்ஜ் மெத்தடையும் இதையும் நான் எப்படி வேலிடேட் பண்றதுன்னு கேட்டீங்கன்னா, வேலிடேட் பண்ணணுன்ற அவசியம் இல்லை. அது வந்து அடிஷன் பண்றதோ இல்ல அந்த அடிஷன் பண்ற மாதிரி தான். அது இண்டஸ்ட்ரியில நீங்க FEA ரிசல்ட்டை எப்படி வேலிடேட் பண்ணுவீங்க? இந்த மெத்தடில் யூஸ் பண்ணி நான் கால்குலேட் பண்ண ஒரு பானட்டை வந்து நான் ரெய்லரிட்ஜ் மெத்தட்லையும் யூஸ் பண்ணேன், நியூட்டன் ராப்சன்ஸ்லையும் யூஸ் பண்ணேன். இண்டஸ்ட்ரியில நான் இதை எப்படி நான் வந்து கால்குலேட் பண்ணுவேன் அப்படின்னு நீங்க கேட்டீங்க அப்படின்னா, இண்டஸ்ட்ரியில you calculated using whichever option, final report will be there. So there will be a standard in which okay, bonnet-க்கு நீ இந்த மெத்தட் தான் யூஸ் பண்ணணும் அப்படின்னு ஒரு ஸ்டாண்டர்ட் இருக்கு. ஏர்பேக்ஸுக்கு இந்த மெத்தட் தான் யூஸ் பண்ணணும். ஏர்பேக் வந்து ஸ்ட்ரெயின் பேஸ்ட் ப்ராப்ளம். ஸோ அதுல வந்து நீங்க ரெய்லரிட்ஜ் யூஸ் பண்ண முடியாது, நியூட்டன் ராப்சன்ஸ் தான் யூஸ் பண்ண முடியும். ஸோ தெர் ஆர் சீக்வன்சஸ் விச் இஸ் பீன் டிட்டர்மைன்ட் பை ஸ்டாண்டர்ட்ஸ். நம்ம ISI-யும் அதை டிட்டர்மைன் பண்ணிருக்கு, யூரோ கோடும் டிட்டர்மைன் பண்ணிருக்கு, ஜப்பான் இண்டஸ்ட்ரியல் ஸ்டாண்டர்ட்ஸும் டிட்டர்மைன் பண்ணிருக்கு. ஸோ இன்டெப்தா போனீங்கன்னா ஒரு காம்பனண்ட்டுக்கு இதுதான் பேஸ்ட் லோடிங், அந்த லோடிங் பேஸ் பண்ணி இந்த மெத்தட்ல நீ கால்குலேட் பண்ணிக்கோ அப்படின்னு சொல்லி எழுதி வச்சிருக்கு. அந்த எழுதி வச்சதையும் எடுத்துக்கிட்டு நீங்க உங்களோட இன்ஜினியரிங் ஜட்ஜ்மெண்ட்டை யூஸ் பண்ணி ஒரு மாடல் ரெடி பண்ணி சால்வ் பண்ணி வச்சுட்டு கையில பேப்பர்ல ஒரு இது வச்சிருக்கீங்க அப்படின்னா, காரை ஒன்று ப்ரொடியூஸ் பண்ணி கொண்டு வந்து இடிக்க விட்டு இடிச்சதுல 10 mmனா உங்க பேப்பர்லயும் 10 mm இருக்கான்னு பார்த்துக்கிட்டா அது வேலிடேஷன். அவ்வளவுதான். அப்படிதான் ஜெனரல் சர்டிபிகேஷன் ப்ராசஸ். ISI மார்க் கொடுக்கிற ப்ராசஸ் இதுதாங்க, வேற எதுவும் கிடையாதுங்க.
தேங்க்யூ சார்.
நோ ப்ராப்ளம் சார்.
Okay, Gaurav. Thank you.
விஜயேந்திரன் முடிச்சுக்கலாமா?
முடிக்கலாம் சார். தேங்க்யூ கௌதம்.
தேங்க்யூ விஜயேந்திரன். தேங்க்யூ சார்.
Thank you, sir.
Thank you, students. Thank you, sir. See you soon. Bye bye.
பை சார்.
Thank you all.